Hello world, it's Siraj, and today I have 5 AI startup examples to demo for you. These examples are projects from the students in my recent course. I received so many amazing midterm submissions. The midterm assignment was to build a paid web app that uses machine learning in some way. It's quite a lofty goal, especially for some of these students who've never coded before. But incredibly, they did some amazing work, and I want to demo their work for you publicly. First of all, just to give them a shout out because I'm so insanely proud of them. And second of all, because this is going to be really useful to you as a tool for inspiration. That's my goal. I want to inspire you to learn more about this technology, right? It's hard to learn anything from a 30-minute, 20-minute YouTube video, but the point of this video, I think, is to act as a gateway for you to use one of the many free, incredible learning resources on the web to learn more about this incredibly cool technology, machine learning. That could be Fast.ai's courses, that could be Coursera, that could be edX, it could be Udacity. There's so many incredible learning paths on the internet, and my goal is to inspire you to take one of them and then just dive super deep into them, all right? So, and here's why this is useful as well, okay? So if you go on GitHub, okay, let's go on github.com together, and we want to search for some machine learning repository or some kind of machine learning code. We'll type in machine learning example, and when we go to GitHub and we type that in, we're going to find plenty of machine learning examples, like assuming we're beginners to this field, and we want to find some example to get us inspired and to get started. Let's take a look here. What we can do is we can go into these repositories and we could see some examples. But the problem with these examples are that they're all training examples, right? They're all about like taking a neural net or taking some model using scikit-learn and training it on some data set. What's really hard to find is a machine learning example that integrates machine learning with a database and with a payment service inside of a web app framework. And the entire stack of an app. That's hard to find, at least in an open source way. But these students have made some incredible demonstrations of that I want to show you, okay? So let's get started with that. The first one I want to talk about is this dermatitis detection service. It is by Michael Chaudhry, Iman Idris, and Dr. Purushottam, which is really cool that they got a doctor on their team for a health tech startup. So that's why I wanted to start off with this one. That's pretty cool. So let's start off with a demo. All of these have web demos, which is awesome. You're going to have a link to everything that I talk about in the video description. All right. So let's start off with the web demo. Dermatitisdetector.onrender.com. And what this does is it automatically classifies some skin disease between 3 different classifications. There's eczema, measles, and melanoma. So I went on Google and I just literally typed in eczema and I found this image. So let's try it out. Eczema, analyze, and the result is eczema. So wonderful work, Michael and team. Very cool stuff. I love seeing that. Now, let's look at the data set that they use to do this. This is an incredibly specialized task, right? Dermatologists do this and they get paid to do this. In order to be allowed to do this, they have to go to 4 years of undergraduate college, 4 years of medical school, 3 years of residency, and then if my memory serves me correctly, 2 years of fellowship for dermatology. That's quite a long time. That's a decade of knowledge accumulation, right, in order to be able to do this. But this does it automatically. It compresses the training time necessary to be able to make that classification down to a few minutes, a few hours, sometimes even a few seconds, just way shorter, orders of magnitude shorter. So, that says something about the field of medicine and where we're heading. Can you imagine where we're going to be 10 years from now if already we can automatically do this task? We can automate diagnosis. We can automate the process of doing any kind of administrative work at hospitals. Electronic health records need a total revamp. The entire medical field will be totally disrupted by artificial intelligence and machine learning technologies. As you can tell, I'm very passionate about health tech, especially AI applied to health tech, because it's just going to make things a whole lot easier. What does that mean for doctors as well? I think that's a good question I've been thinking about myself. It means that doctors will continue to have jobs, but a lot of their tasks will be automated, which means that they will focus more on the empathetic aspects of medicine, the human aspects, caring for the patient, relating to the patient, things like that. But the actual diagnoses themselves and even the surgical interventions, I think will, in 10 years from now, totally be automated, at least at the highest levels of society where they have the money for that. And then it's going to be democratized from there. So yeah, little healthcare tangent, but back to this. Back to their the data set they used. They found this data set and then they put it on Kaggle. And they've got eczema, measles, melanoma, and they have about 400 examples, which is, you know, it's good. It could definitely be better for sure. But this was just a prototype. So if you want to check out their data set, just go to Kaggle, which is super cool stuff. And they have some code as well. Now, this version of their code is not the final version. Like they're going to have a login page, they're going to have a paid. Right now, it's only a donate button, but they're going to have a version 2 of this, version 3 of this, and they're probably going to keep it proprietary. I hope, because I want them to actually make some money with this. But this is just as an example of like the first version to give people some inspiration. So let's take a look at their code here. So they have this Jupyter notebook that basically uses fast.ai to classify those images of skin disease. So by the way, before we go into that, let's talk about the tools that they used. So these are the tools that they listed that they used. They used PyTorch, which is a deep learning library, right, for being able to do all sorts of neural net classification, regression, and all of those tasks. But they didn't actually use PyTorch. They used fast.ai. What I mean is fast.ai can use PyTorch under the hood. So this is like the wrapper that they use, fast.ai. Now, in general, let's talk about this framework. I am seeing more and more use of this framework across the community. Like people really love fast.ai's vision library in particular. It's super easy to use, and I like it myself. Like super endorsement. Great stuff. Also Starlet, they use Starlet. So Starlet is a web app framework. It's kind of like Django, it's kind of like Flask. It's just a newer one that it seems to be very lightweight and more production ready than the other ones. So they use Starlet for the web framework, and then they use PayPal for the payments. Now if we look at their code, we'll see that, okay, they've uploaded those CSVs, they're viewing the data. Look at this training process. It's just CNN Learner, and then under the hood, you can see it's using the PyTorch ResNet model, but super easy to use. You can see that it's all like one-liners, all of this stuff, which is why it's so simple to get started with. But these are convolutional networks. They're great for image classification, and they basically they're serving that as a web app. So if we look at their code in server.py, which is the main file here, we have, first of all, they're retrieving that trained model that they saved on Dropbox. They're initializing the Starlet web app. They're saying these are the 3 classes we want to classify. They have 2 helper functions, one to download a file and one to set up the actual training process or the inference machine. And then they start this asynchronous event loop, which is this cool thing about Starlet, which allows it to take both synchronous and asynchronous calls, which prevents the user interface from being blocked whenever anything is being retrieved. And then we have our analyze function, which is what's called whenever we hit that analyze button, and you can see inference happening right here at learn.predict. Cool, right? So that's like the highest level of that. You can see in the requirements, they use PyTorch, fast.ai, and then a few like little helper files. But that's really the gist of this. Okay, so by the way, like I said, all of these resources are going to be in the video description. Let's move on to example number 2. This one was super cool. So this was a script generator by Ralf Greschner from Germany. Hi, Ralph. Great work. I really liked it. So in his demo, he basically had this AI-generated transcript machine, which essentially generated scripts for the TV show Star Trek: The Next Generation. And this is aimed to be a tool for people in the creative industry to help writers and create these proposals automatically, writing prompts. Basically, it's a tool for creativity. So first of all, we'll authenticate, and this he's got Google authentication working on here, and then we'll generate the script, and it says, okay, you need to pay. Okay, great. This is obviously a test, so we're going to type in some test card information, and we'll pay. Okay, generating a script. And we've got some scripts here. That's too bad, said Beverly. I want to know how they're getting along, said Picard. The Ferengi are becoming more confident in their abilities. Data, what if I may? Data nods, shrugs. Okay, so it could be a better, but it's a really cool start. It's an example of a generative model in a web app, which is extremely hard to find. A generative model in a web app. So proud of you, Ralph, for doing this. Great work. Now, how did he build this? Well, first of all, he used Docker. Docker is kind of like a virtual machine, but much lighter, right? Because a virtual machine needs a lot of different components, but sometimes you just want to have your app run in a containerized environment where you only need to have those dependencies necessary for that app. You don't need the entire bloated virtual machine. Docker is super popular for that. It's easy to get started, to install some project. You just have to, if you have Docker running, it can just immediately pull the dependencies. It makes installation and configuration a lot easier. Now, they also use nest.js. Nest.js is basically a wrapper around node.js, the popular web app framework in JavaScript. And the other great thing about nest.js is that it's got OAuth integrated, all sorts of OAuth schemes, specifically Google OAuth, which we just saw used in that web app. He used Angular, which is for the front end. So the back end was Nest, the front end was Angular, and Angular is basically a really pretty framework. It's part of the mean stack, Mongo, Express, Angular, Node, in web lingo, and it basically uses the power of model view model, which is a very popular web architecture type. It's kind of like model view controller. We won't get into all that right now. And then lastly, the AI part that they used was GPT-2 by Minimaxer. So this is a really cool Python package, which basically you just do pip install GPT-2, which is the OpenAI text generator, the famous text generator. And then you can just generate text super easily with just that single package, right? So pip3 install GPT-2 simple. And then just like this, we can say, hey, fine tune the Shakespearean text, or, generate some text based off of this seed text. And it will do that for you super easily, which is amazing. Like what a cool Python package. Good job. So there's that. And let's look at his code a little bit as well. Okay, so let's download that. Let's just peek into it and see what it's like. Sublime. Okay, so we'll go into backend. We'll go into main. TypeScript is what's generated by the type of web app that he used. TypeScript is basically just JavaScript, so don't get too weirded out by looking at TypeScript. What I want to find is the script generation, right? So the AI part. That's it. Look at that, GPT-2. That's the AI code right there, And so this was called by the rest of the functions. If we go to, package.json, here's some of the files that were necessary. There's our script generation service. He's got a bunch of functions for script generation, which is super cool. And some amazing write-ups here. Like this is going to be super useful to read as well as a learning tool, like his process of going through this and finding out what worked and what didn't work and what were the steps. Very, very well documented. So proud of you, Ralph. Good job. Good job. So moving on to example 3, we have a cryptocurrency price prediction app by Amila Mutunayake. Very good work, Amila. Like I really like this one. This one was pretty cool. So she used the Yahoo Finance cryptocurrency API to pull different prices from the web. So let's say that I'm on the free plan and I want to predict the conversion rates from BTC to USD. I can just choose those out of all of these. And then what it's going to do is it's going to perform inference in the background to be able to make a time series prediction on what the future conversion prices will be starting today for the next 5 days. And you can see the 5-day prediction here. Now, how accurate is this? That is debatable. I don't know. I haven't looked into it that much to know how accurate it is. But what I can say is that this is super cool, right? That's a pretty cool a web app to make. So that was the demo of the Crypto Predictor app. Now, how did she build this? Well, first of all, she used Flask, which is the Python web framework for building web apps in Python. And then in order to make that prediction, she used a long short-term memory network. Now, I've talked about this quite a lot on my channel. In general, if you want to learn about LSTM networks, just type in LSTM network on YouTube. You'll find so many videos at this point by a variety of creators on how those work. But the basic idea is that these are types of neural networks that can learn on sequences of data, and they can learn on not just any types of sequences of data, but on long sequences of data. It's like they have a long-term memory associated with what happened way back in the past while they were training. You know, they can relate the first paragraph of some novel to the page 382. If it's making the prediction of what's going to happen on page 383, it'll take everything into account. Okay, so that's the idea. Now, this time series example applies to crypto prices because they are also sequences. They're sequences of numbers. They're time series. If we can compress all that information into a representation, we can then use that representation to make a prediction about what the future prices will be for this. Now, so those were the two main tools that she used for this. And yeah, just like a really cool app idea. I love it, Amila. Really, really good work. If we go to that app and we open it up, let's take a little peek inside of here and see what's in here. Okay, quite a lot of helper functions here. In models, so this is one thing I really liked about Amila's code was that she created classes for all of her objects that she wanted. She created a class for a user, created a class for a post, right? So this is just good object-oriented programming in general, right? To create objects for all of the components of your app and to know what they are beforehand before you start building. Bunch of login pages, and then inside of posts we have routes. So here is where the predictions are happening right here, post/predict. It's taking the date time, it's taking all of those prices, and it is adding labels to all of those dates. And then she's using Keras it's a neural network. What type of network? Looks like a feed-forward network with like 3 layers, maybe 4, to train on that data. Okay. And then graphing it out for the 5-day prediction. Cool stuff. Now, that's really the main component here. That's the value, but the rest is just kind of a wrapper around that. Now, on to example 4. Now, this one is extremely exciting because they didn't even want to give me the full code because I think that they're actually going to turn this into a legit startup. And not, I think they are. That's their intent. That's what they told me. Shumik Goswami, Tejas Kumar, Shant Behera, and Sophie Zhu created an automatic threat detection app. Now, what this does is it's for airports, for all sorts of security access points where you have to scan your luggage, right? So right now we have a human who's scanning the luggage, classifying whether or not there's a threat in there. You know, some kind of a negative item that we don't want on a plane. And we can automate that if we just think about using a convolutional network. So that was their idea, that the scanner will generate an X-ray image. They created an API called DetectX to scan that image that these services can use, governments and organizations. And it will analyze the encrypted image and it will send back the result, which is whether or not there's some dangerous item in that luggage. Now, this is a super useful tool, both to replace somebody who's doing this or even to start off to augment someone who's doing this and give them a second opinion. And so you can see a demo right here where we say analyze this image, detect danger equals true. Now we'll do it for a different one, and obviously there's some dangerous images in there. Dangerous equals true, right? Now, that's super cool. And they have this free $25 a month and then pay-as-you-go plan, which is super cool. I love that. And basically, another thing I really liked about their app was the fact that they used Postman to generate some API documentation for them. Like, this is their API right here. So what you would do if you're an organization and you want to use their service, you would make a post request to their API right here, and you would ideally pay for it. And then you could see, you could basically classify things automatically as much as you want to. Super useful little graphic that they made here as well, like pretty stuff. Like this is the kind of thing you need, to be successful as a startup. You need to have good design. If you think about any successful anything, they didn't skimp on anything. They were just 100% on everything they did, which is something that's inspiring for me and hopefully for you too. So great work, guys. Like really, really cool stuff. Amazing team. I love your little graphics here as well. Little faces. Good stuff. So they didn't want to give me like the full demo, but they did give it because they're actually gonna, start making some money off of this. But they did give me this Jupyter notebook, which is super cool, which allows us to see how they built this. And what did they use? They used Keras. They used Keras to do this, which is a good choice of library to use. And they trained it on that data. But what was that data? Let's take a look at that data. They had some X-ray data from the Department of Computer Science in Chile and 2.9 gigabytes of baggage. And this looks like it was labeled data, whether or not it was dangerous, which is great. Good stuff. So very good stuff. They used Keras. They used Render to host it. By the way, I've been telling everybody to use Render in general. Yeah, Render is just super cool. You can really easily upload a web app to this service directly from GitHub as well. And I just really like it now. It's like my new Heroku. Render is deploy in seconds, update automatically directly from GitHub. That's what I'm talking about. That's that continuous integration pipeline that I like to see. So good job, Render. Love that. So, okay, moving on to the last one, example 5. Now, for the last example, we have a resume rater service. Now, this is by Zheng Ser. Good job, Zheng. Basically, he created a service that allows you to upload your resume and see a % match of how close it is to the job description that you are applying for, which is super useful because sometimes we don't know, like we are trying to guess how good of a fit we are for a certain job, and this kind of puts a number to it, like literally puts a number to it, which is really cool. And what Zheng did is it's a very simple web app, but the idea itself is extremely powerful. He used Flask as the web app framework, and then scikit-learn as the machine learning library to perform that machine learning, pandas for the data preprocessing. But I wanna really focus on his code here for a second because he did something really interesting. Okay, so let's think about this problem together for a second. Okay, so let's assume that we wanted to create a service just like this. Now, how would we do this? How would we design a resume scanning service that would output a similarity score for how close our resume was to a given job description? Well, we would want to convert both of those documents, both the resume and the job description, into some sort of vector representation, right, in vector space. And then we could just perform a subtraction to find the difference between those two, like how far are they from each other in vector space, and use that distance as the actual metric that we're looking for, right? What that means is, there's several ways that we can do this. But what he did was he used this cosine similarity metric, right? So that's super smart. There was not even a training process there. I mean, there was a training process in that you're fitting those documents into a representation, but it's not like it's learning previously and then applying inference. It's online learning. It's learning in real time. It's taking those two documents, converting them into vectors, and then finding the cosine similarity between those two representations, those doc term matrices, and then outputting the result, which is, it works. Like, that's a useful tool. So that just goes to show there's a lot of different ways to incorporate learning into your web apps. It doesn't always have to be like learn beforehand and then apply. It could be, cosine similarity, or one of those other online learning, like real-time techniques. There's a lot out there, like, what was that one? Latent Dirichlet allocation, LDA. I think that's an online learning one. Don't quote me on that one. But that one sticks out, latent Dirichlet allocation. So super cool stuff. He used Stripe for the payments. Good job. Look at this. Look at this these routes. I love that. I love that, especially because it's just so much progress in such a short period of time. Like, it's incredible. Like, super proud of you, Zheng. Good job. Okay, so All of these are going to be in the video description. I'm going to have links to everything. The point of this video, as the point of all of my videos moving forward, are to inspire you to learn more about this technology. I am an inspirer. I love this stuff. I'm not a PhD. I'm not a, professor at a university. I'm just a guy on YouTube who absolutely loves software, and I want to create more experts in the world by inspiring them to learn more about this technology. So please go through all of this code in the video description. Take your time, enjoy it, and enjoy learning, because this stuff is super cool. It's going to take over every industry, and I want you to be a part of it. So thank you so much for watching.